Okay, so now let's start with dangling pointer. What is a dangling pointer? It is a type of pointer which is pointing towards such a memory location which has been already deleted or deallocated. So it's a kind of problem because your pointer is unnecessarily pointing towards already freed memory location. There are various scenarios where we can see dangling pointer situation. Now what is the solution for this problem? As soon as the dynamic memory is deleted or deallocated, the pointer which was pointing towards the dynamic memory should be assigned with a null address value. Now when null is assigned to this pointer, the pointer will no longer will be a dangling pointer. So primarily there are two cases where we can see dangling pointer situation. The first is compile time or static time memory allocation case where variable goes out of scope, and when variable goes out of scope the pointer becomes a dangling pointer. So let's see. In the main function we have a pointer. Currently it is not pointing anywhere. So in the main function we have a local block. In the local block one variable is created v with value 23 and pointer has started pointing towards v. Now when we print the address of ptr, compiler will give some address value and that address value will be of v. Now when the block is over, we know what happens. The variable v will be destroyed because v was created inside this local block. When the local block is over, v will be destroyed. Now again if we print the address held by ptr, it will give you the same address that it gave earlier when it was inside the block. Now inside block address and outside block address values are same. It means it is a dangling pointer situation because pointer is still pointing towards that memory location. Now that memory location was actually v, but v is already destroyed. So if v is not existing, then why pointer is pointing towards that memory location? It's a problem. So what is the problem here? It's a dangling pointer situation. Now what is the solution for this problem? You can simply assign null to it and then the problem will be solved. Now this is compile time memory allocation case. Now in this chapter we are focusing on runtime memory allocation or dynamic memory allocation. This is the dangling pointer example number 2. Let's see with the help of compiler. I'm taking the same program here in the compiler. Now there is a pointer p which is initialized with null value initially. So it's a null pointer in the initial phases and then p is equal to new of int. It means one memory location has been reserved at runtime. We are checking for memory allocation failure that we have discussed earlier. If sufficient memory is available, then there will be no memory allocation failure. Now in the next part what we are doing, we are giving value to that memory which has been allocated at runtime. We are printing the address held by the pointer before deallocation of memory. Then we will deallocate the memory, and after deallocation again we are printing the address held by the pointer. Now if the both address values are same, it means p is a dangling pointer. Let's verify. You can see compiler is assigning same address to p. So it's a dangling pointer situation. Now what is the solution for this? We can simply assign null to it. Now it will be no longer a dangling pointer. We can verify also. You can see this is after deallocation. It's a problem. Now it's a solution. Now it's no longer a dangling pointer. So new will assign some address and that address will be of dynamic memory, and before and after the pointer is pointing towards that dynamic memory, although after deallocation of memory that memory is no longer into usage. So why pointer is pointing? It's a problem. It's a dangling pointer. So the solution is null. Thank you.